So, when you look inside the cockpit of a modern airliner, how does a pilot actually fly the thing? Well, it really boils down to two options, a yoke or a sidestick. But this isn't just a simple choice of hardware. Oh no, this is a story about two completely different philosophies from the world's biggest rivals, Boeing and Airbus. And it's a story that has had profound, life-or-death consequences for the crews and passengers who trust them.
Alright, so let's dive right in. To really get this debate, you have to understand that we're not just talking about pieces of plastic and metal. We're talking about the core ideas driving the design of two totally different flight decks. And this, right here, lays out the whole conflict perfectly. On one side, you've got Boeing. Their philosophy has always been that the pilot is the ultimate authority. Sure, the automation is there to help, but the pilot can always push past what they call soft limits and take full control. Airbus, on the other hand, comes from a different place. Their fly-by-wire system has hard limits. In its normal mode, the computer will literally stop a pilot from making an input it thinks is unsafe. It just won't let you stall the plane.
And believe me, this isn't just some academic difference. Pilots feel this in their bones. I saw this great quote from a pilot over on Reddit that just nails it. He said, "Flying an Airbus A320 is like a comfortable video game. You're making requests to a super smart computer. But the Boeing 737, that's like flying a dump truck. It's heavy, it's direct, and you feel like you are physically flying an airplane."
Okay, so let's talk trade-offs, because that's where this all gets really interesting. The yoke is big and bulky. Yeah, but because the two are physically linked, the pilot and co-pilot always see and feel what the other person is doing. The sidestick, though, saves a ton of space. You know, that famous Airbus tray table, and it's way lighter and more ergonomic. But, and this is the absolute crucial difference, in the traditional design, the two sidesticks aren't linked at all. They're what we call passive. They're totally independent.
And that one little detail, that lack of linkage, well, for years it was just a theoretical debate for engineers. But on the night of June 1st, 2009, high above the Atlantic Ocean, that theory became a horrifying and tragic reality.
It's just chilling how fast everything fell apart. In less than 5 minutes, Air France 447 went from a routine flight to a catastrophe. It all started when ice crystals clogged the airspeed sensors. The autopilot clicked off. In the confusion, the co-pilot in the right seat yanked back hard on his sidestick, putting the plane into a climb it couldn't sustain. A stall warning started screaming through the cockpit, but those nose-up inputs kept coming, completely unheard and, more importantly, unfelt by the other pilot.
And this is why. The Airbus A330 had a passive sidestick. So the pilot in the left seat had no physical clue, no tactile feedback whatsoever, that his colleague was holding that stick all the way back, literally holding the plane in a stall from which it would never recover. So this brings up a really terrifying question, doesn't it? If one pilot can't feel what the other is doing, what on earth happens if they make opposite inputs at the exact same time? You know, one pulling up, the other pushing down.
Well, the answer is just awful. The system simply adds the inputs together. Think about that for a second. A full nose-up command from one pilot and a full nose-down from the other, they literally cancel each other out. The plane's control surfaces get a summed input of 0. The pilots are fighting for control, but they're fighting each other, and the plane doesn't respond. This wasn't a hypothetical. This is exactly what happened in the final, desperate moments of Air France 447.
That tragedy threw a massive spotlight on this critical communication gap in the cockpit. And in response, the industry basically hit the accelerator on developing a piece of technology designed to bridge that gap forever.
And here it is. Meet the active sidestick. Now, this is a whole different animal. Instead of being passive and independent, these sticks are electronically linked. They use little motors to provide force feedback, which means whatever one pilot does on their stick is instantly and perfectly mirrored in the other.
The way it works is actually pretty brilliant. Pilot A moves their stick, an electronic signal zips across the cockpit to Pilot B's stick, and boom, both sticks move together in perfect sync, just as if they were physically connected. That critical human-to-human feedback loop is back in business.
And this is why the active sidestick is such a game changer. It really is the best of both worlds. You get that crucial cross-cockpit feedback of a yoke? Check. But you keep the clear view of the instruments, the great ergonomics, and the weight savings of a sidestick. It solves the single biggest drawback while keeping all the advantages.
So you see, we're not just talking about some minor component upgrade. This technology represents a potential turning point for cockpit design across the entire industry.
And look, this isn't science fiction. It's already flying.
Gulfstream was the first to get it certified in their awesome G500 and G600 business jets. You can find it in military transports like the Embraer KC-390. This is proven, next-generation technology that's in the air right now.
Which, of course, brings us to the big question. Will Airbus, the company that pioneered the Sidestick in the first place, adopt this new active version, and maybe even retrofit its thousands of existing aircraft?
And what about the other guy? What about Boeing? Could a piece of tech that gives them the exact pilot-to-pilot feedback they've always championed, could that finally be the thing that convinces them to ditch that bulky, century-old Yoke?
It really leaves us with a final thought. Perhaps the next great leap forward in aviation safety isn't just about how pilots communicate with the airplane. Maybe it's about using technology to make sure they can always and clearly communicate with each other.